We are ready to pick up, I believe, in your class with absolute value. We finished 12, then we'll look at some questions. Absolute value function is 1. I would like to think we know. If not, do it on the calculator. Do you remember where to find absolute value on the calculator?
Yes, the alpha.
I do alpha F. Is it F2?
Yeah.
It's in the alpha F2 shortcut. It's also in menu or math menu if you arrow over 1 to num. But you will find this to be what I always say is the absolute value V. Okay. What kind of domain does this have?
Negative infinity?
Yeah.
Yeah.
It goes infinitely left, infinitely right. It's all real numbers. So negative infinity to positive infinity. What kind of range do we have here?
0 to infinity.
Okay. This goes as low as 0 and up to infinity. Are we touching 0?
Yes.
Yes, so it's going to be a bracket on 0 up to infinity. Okay. Greatest integer function. Got any thoughts?
No,
X in parentheses.
you got me lost on that
Oh,
one.
have you tried it?
No.
It doesn't work.
If I put x in parentheses,
Gives me a failure.
Looks like it's just a straight line. Okay, let's put it.
okay, which, so there, you'll notice it shows brackets, but I don't know, does that even allow you to graph it?
No,
I didn't even know you could put brackets in on a calculator.
it's
Yeah.
second and multiplication.
So, okay, is everyone on their calculator and following along?
Sure. Yes.
What, in order to graph this on the calculator, you have to use this function right here, int. I don't think it's in my alpha shortcut menu. You need to go into math. So find your math button here on the left side of the calculator. And then I believe
Function E.
you arrow over 1 to the num menu.
Oh, it is number 5.
And then it's number 5 on the num menu.
And X plus.
Okay. Then, so it brings up int. You have to fill in x and the parenthesis. And you get a graph that looks like such.
What the hell?
Talk about stairs.
Okay. Okay.
Negative
So-
infinity.
Hold on.
Now.
Oh my goodness. Physics, I cannot get the right answer the other day, and I could not figure it out, and then I realized I didn't have my calculator switched.
Did you switch back to
Mr.
degree?
Kevin told me to switch it. He's like, because we're doing trig, and I'm getting the same answer as everybody else, but I'm not getting the same number. I was like, what the heck?
It's a straight line.
Okay. Are the calculators cooperating?
You just gotta zoom out enough. Alright.
Okay, now, I want to be specific as I draw this. I'm going to draw just a few of the, quote, stairs. Okay. But as we draw this,
Looks like straight line.
I'm going to label 1, 2, and we'll go over to 3. I'll go -1, -2. We might make it over -3. And then going up, I'm going to go 1, 2, 3. So basically I'm labeling 3 in each direction. Okay. And the idea as you graph this, folks, is they are little straight lines. Now, what you can't see by looking at the calculator is that they are little straight lines. Specifically, though, with closed circles on the left end and open circles on the right end. So like the first line I drew, just to kind of give us a center base, is the line on the x-axis from 0 to 1. Then at 1, you hop up to the y value of 1. You'll have a closed circle going over, and you'll have an open circle above 2. Above 2, you hop up to the y value of 2. And again, you have all these little segments, okay? They are always lined up with the integers, okay? So the ends are always lined up with the integers. We can also reverse this and have a line down at -1. Again, the left end is always the closed circle. Right end is always the open circle. We can go down again. And I guess I'm set up to go down once more. Okay? As you saw in your calculator, it looks like stair steps, but it is important to notice that these stairs aren't connected. Okay, that is important to notice as we start to talk about domain and range.
I believe range is still next.
Okay, let's start with domain.
Interact.
Domain. What are we thinking on domain? Negative infinity to positive infinity? Are we including everything?
Yeah.
Okay, so if you start following over, every time you hit that open circle, what happens? It lines up with a closed circle. So if every time it lines up with a closed circle, then yes, everything is included. And so our domain is negative infinity to positive infinity. Okay? Now, range.
Don't you have to list like all the numbers?
This is a bit of a sticky wicket.
Okay? We're not going to list all the numbers, but it is essentially what it
Or is
is.
it like
We're
the-
gonna I have a way we're going to do it, but
I forget what they're
because
called.
here's the deal. Range are my y values. Are we using all the y values?
No, isn't that where you do the little squiggly guy thingy? I forget what they're called. Like
The brace?
brace, yeah. Don't you use those?
Again, I have a different way. I was just going to use 2 words. So, now, what kind of numbers are these in our range?
Real?
And everything's real in the graph.
No.
Are we including decimals?
Just no. Hold on.
Whole numbers would indicate only positive. It's positive and negative whole numbers, which has a word.
Is it in this chapter? I don't think so.
Begins with I,
Integers.
integers. So how I have my range listed is all integers. Because that's what it includes. It includes all integers infinitely.
All
Okay? Which is why we're not going to write a list of numbers, because it goes on infinitely and that would be really difficult to do. Okay. And then our last graph to talk about is the logistic function. I would suggest you grab your calculator and practice graphing that.
She's great.
I mean, it's not as tricky as knowing where to put in the other one, but there are some mistakes that can be made there.
Where are we
1 over 1 plus e to the negative x.
Where are we grabbing this E from?
I like to use the e that is on the left side down above ln, where it says e to the
E
x.
to the X, yeah.
You could also grab e from above the division symbol, but then it just doesn't have the exponent box with it.
Can't see.
Boom, graph that. Graph that.
What do we see happening here?
She looks like the exponential function. Oh, what? How is mine different? Hold on. Oh, hold on. Boom. Boom.
What can you tell me about this graph?
The mine does not look like that. Maybe it does. Maybe it does not.
I have mine on Z6.
That I know mine work it.
Okay.
That doesn't matter.
I have just Z6 is what I always start on until I decide to go from there. Now, if you hit trace, notice it pops you up at 1/2 on the y-axis. If you start going left, what's look like is happening as we go left?
We're getting closer to 0.
Yeah. As you go left,
But we're never
you're not
touching.
crossing the y-axis, are you? What about as you go right of the x-axis? What's the graph doing?
Going up, open up,
Going up. How far is it going up?
just a half.
How high do we go? What are we not crossing?
1.
Not crossing 1 because I'm at a
Oh, wait, keep going.
0.99998.
You think it'll go up? What
It
does
does.
go next?
It does. It gets you to point. Yeah.
Oh, we touched 1.
Oh, it actually it claims it touches 1, but it doesn't.
Well, calculator said yes.
So.
Well, your
It
mom.
does.
Your mom says no.
Okay, enough. With this in mind, this function is the logistic function. And the logistic function is this curve right here. It runs between the 0 and the 1. It doesn't go below 0. It officially doesn't go above 1. I think that's the calculator rounding. I'm kind of surprised it rounded as far that to 1. I'm going with graphing calculator error, you know. So what's my domain here?
Negative infinity, infinity.
Okay, negative infinity and infinity. So it's going infinitely left and right. What about my range? How low does it go? How high does it go?
0 to 1.
0 to 1. Parentheses or brackets?
Parentheses.
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 And even though it showed me a 1 up there, I'm still going to go parentheses because I know what the graph is supposed to do. Okay? Now, your homework has a couple of different things in it. As I said, you start off with a matching set. They give you an equation. They give you 12 equations. They give you 12 graphs. And you're matching them. Now, the key is it's not just x squared, for instance. It might be y equals x squared minus 3. It's not just x cubed. It might be 2x cubed minus 4. You know, in other words, it's going to be variations of these. Your job is to be like, oh, there's an x squared. Oh, there's something that looks like a parabola, and match them up like that. Last ditch effort to check yourself. Can you go to the calculator and punch them in? You can, but that's not what I want you to do first. Okay? Because your job is to be able to kind of match these, try to match these up. Okay. So, our job here is to go through and answer some questions. Okay, I'll provide these questions and homework. So, only 2 of the 12 functions have points of discontinuity. Are these points in the domain of the function? So, first of all, let's start by trying to find which 2, yeah, you're just going to have to flip back and forth, which 2 have points of discontinuity.
One of them is. I think one of them is. I can't find another one on the domain. So
Which one are we thinking?
the fourth one, reciprocal function.
Okay, so let's talk about reciprocal function, because I definitely agree with reciprocal function. It has a point of discontinuity because it has a break. It's the idea of, can I take, when we talk about if it's continuous, can I take my writing utensil and draw it without picking it up? Okay, the reciprocal function has discontinuity because you can't be drawn with one swipe.
And
Okay,
second one, the
Yeah.
greatest integer function.
okay, your greatest integer function is the other one because I can't draw it in one piece. Okay, so we're going to talk about these two.
Greatest integer function. Bottom of
Reciprocal,
Discontinuous domain.
but you can't draw it without picking up.
greatest integer. Well, the first question was, only 2 of the 12 functions have points of discontinuity. So we have to figure out which 2. Okay, and that was reciprocal and greatest integer. Now, in the homework, if I recall correctly, I did more of a listing the equations. So what's the equation for reciprocal?
1 over x,
1 over x. What's the equation for greatest integer?
int.
You can do int x is what we usually do. You can do x with the bracket, but I think more than likely what you'll see is the integer one. Okay? Now, are these points in the domain of the function? Okay, so where is the reciprocal function discontinuous? Where does it have a discontinuity?
0.
At 0, yes? Okay, so then the question is, are these points in the domain? Is x in the domain? Is 0 in the domain?
Yes.
Reciprocal, yes.
Yes.
Is 0 in the domain?
Yes.
Is it included in the domain?
No.
We wrote it, but is it included in the domain?
No.
It's not in the domain. Okay,
Is
Whoops.
the domain of the function uses?
so on this one, I'm going to say no. X equals 0 is not in the domain. Okay.
Yes. Next.
Greatest integer function. Where is it discontinuous?
At like -2. Or would that be like all of them, like -2, -1, 1, 2, 2?
All of the integers?
Yeah.
Okay. Now, are integers included in the domain?
I'll say yes.
Yeah, they are, aren't they? So it's discontinuous at every integer value, but those points are in the domain. Okay. I'm going to say at discontinuous at each integer. And then I'm going to say in the domain.
So why would that not be, it would be discontinuous?
Continuous in the range of every integer.
We're not, when we talk about continuity, we're talking in terms of x values. We talk about the location of the discontinuities in relation to x. Well, but okay, so if it's a if there's some kind of discontinuity, there's lots of different types of discontinuities, but it means you can't put that writing utensil down and draw it without picking it up. Since you're drawing lots of little lines, it's discontinuous because it's like draw a little line, move my pencil, draw a little line, move it, so on and so forth. Okay? Now, example 2. Only 3 of the 12 basic functions are bounded, both above and below. So now we're going from lesson 1.2, the vocab word bounded. So there are 3 that are bounded.
So it's got to be both. It can't just be on one side.
Right, no, it's not above or below, it is bounded both.
Cosine, sine.
Yeah.
Would you say back?
Okay. So bounded. Are sine and cosine 2 good ones to look at?
Yeah.
Because what's the thing? Do they have heights? They never go above and below. Yeah, sine and cosine definitely. And is there another one that doesn't go below and above a certain height?
I actually said the logistic.
Okay, logistic function, because it doesn't go below 0 and it doesn't go above 1. So that is a matter of looking at your range. Okay, those are the only 2 that don't have an infinity, or the only 3 that don't have in some kind of infinity in their ranges. So I'm going to list the words, but here's the deal. On the answer key, it's going to say y equals sine x. It's going to say y equals cosine x and y equals 1 over 1 plus e to the negative x. It doesn't hurt you to write the words out so you can learn them paired up here. Okay. Example 3. Give everyone a moment to think before we start talking. 3 of the 12 basic functions are even. Now, let's review for a moment before we talk about which ones. Even. Does everyone have an idea of even? Because this goes back to lesson 1.2 also. What's even mean? Yeah. So if we talk even, it's symmetrical across the y-axis. Now, we could also say f of x equals f of negative x, but here's the deal. That's not really a helpful tool. The symmetric across the y-axis is what's most helpful there. So, we're looking for 3 of them. Give me 1.
Wait, I don't want to do that one. Actually, I'm gonna try that one. Would the cosine function do one technically?
So can I fold my paper in half at the y-axis and it land on top of itself?
On mine, you can.
Okay. Yes, the cosine function is 1. So I'm going to write cosine, but realize the answer key is just going to say the y equals cos x. Okay. What else? Okay, squaring function, aka our parabola. That's symmetric, yes?
Yes.
So squaring,
Bring out the
y equals x squared.
Actually, you know what it is.
We need to call the substitute.
Rebecca?
Absolute value.
Absolute value.
Rebecca.
That v, it folds in the middle.
Oh no.
Rebecca's the designated
Actually, it's the
Okay.
reliever that gives up the 3-run homer. Loser.
Okay, focus, guys. Absolute value is our third there. Okay. Are you getting the idea of just, you're looking for which ones match whatever they're asking? Okay, you're going to see a variety of questions in homework. It's, we're getting to know the graphs here. Okay, so use your page of 12 graphs to help you out. Now, example 4. This is either 34 and 35 or 38 and 39 are like this. Actually, it's 35, 38, 39, 41 are like this problem we're getting ready to do right here. Okay? Okay. Graph the function f of x equals x minus 2 squared. And then we have some questions to answer about it. So first thing I'm going to do is I'm going to sketch a graph over here. So we have a graph to reference. And I know you guys are using a calculator, which is fine, but what is the shape?
A parabola.
A parabola. And what does that minus 2 do?
Move it to the right too.
Yeah. Minus 2 in the parentheses takes your graph and moves it to right. There's your Algebra 2 review for the day. Okay? And so that means my vertex, if you graphed on your calculator, is over here, yes? And I'm not getting that picky. It's a parabola, okay? Now, let's talk about the first question. On what interval is the function increasing? And then where is it decreasing? So what do we know about increasing? Let's start with increasing. Logan?
Going positive. I mean, like, I failed.
When is it
I'm gonna
increasing?
say bracket 0 to infinity.
Wait.
No.
Bracket 2.
Yeah, two.
Bracket, comma, infinity.
Okay.
Oh, it's gonna be
Yeah, you let up the 3-run home
It's gonna
run.
be X value. Yeah.
Okay, so when we give our intervals for increasing and decreasing, we are going in terms of x. The x value that this changes at is at 2. So increasing is going to be 2 to infinity. Infinity always uses parentheses, and 2 is a bracket here because it's touching the point at 2.
To infinity.
And then
You can't lie, that was a
Decreasing.
good one. Negative infinity down to 2.
Okay, so, and maybe we should have started with decreasing, but the graph starts off decreasing, doesn't it? As it comes from the left, it's decreasing, and it's decreasing all the way to 2. So, negative infinity to 2 with a bracket. Okay? Is the function even, odd, or neither?
It's gonna be
It's not even.
So what was our definition of even?
Across the y-axis.
Symmetric across the y-axis. Is it symmetric across the y-axis?
No.
No, it shifted over. What's our definition of odd?
symmetry about the origin.
Symmetric about the origin. So, loosely said, that means there has to be something similar to this reflected down in the diagonal quadrant. Are we symmetric about the origin? No, because symmetric about the origin, you'd have to be able to take the graph, reflect it across the x-axis and across the y-axis. So if it was symmetric across the origin, we'd have a parabola down there, if that makes sense. That would be symmetric across the origin, which we don't have. So what are we going to say here?
So neither.
Neither.
What's extreme again?
Infinity.
Okay.
Same thing.
Very
Then,
extreme.
does the function have any extrema? Did anyone find the vocab word?
Well, what lesson were we
No,
at?
it's too late.
It was in one of the, it was part somewhere in lesson 1.2.
1.2, guys.
Well, there's
Yeah,
like
there's three
parts.
I know.
Hold on, we'll find it. Don't worry.
It's not part one.
Extrema are the hills and valleys of our graphs. A local minimum or maximum is one of the hills or valleys of our graphs. An absolute maximum or minimum is the highest or lowest point that the graph ever goes.
Okay, thank you,
It
Logan.
has extreme.
Okay, so does the function have any extrema?
Yes.
Yes. What do we know? What is there?
Down below, it's a minimum.
There's a minimum at what point?
2.
See,
Okay, at x equals 2, or I'm going to say at the ordered pair 2, 0.
you have to define minimum and maximum. You can just write x equals 2.
To me, it would be better to define which it is. I don't know if you have to or not, but. And then D. How does the graph relate to the graph of the basic y equals x squared? So this is way back in Algebra 2.
Oh,
Algebra 2 roots here. How does it relate to the original graph y equals x squared?
It is shifted to the right to
Translated.
Translated. Hey,
Translated.
you're the one who put your hand down. I want to hear it all.
Okay, so,
You.
gentlemen, settle. Translates right to units. Okay, translates right to units.
I guarantee you if I put shifted, same.
It's okay, I thought shifted was better.
Why'd you say that loud? You don't have it right. It's alright, McKenna.
Okay,
You got next one.
are we good on this one?
Yeah.
Your last 4 problems of homework are doing exactly this. Okay,
Pretty simple.
so, okay, 2 more questions. Example 5. 2 of the basic functions had vertical asymptotes at x equals 0. Which 2? Now, what do we mean x equals 0? What's another name for x equals 0? It's the what axis?
Y-axis. Y-axis.
The y-axis. So I'm looking for 2 functions that have vertical asymptotes on the y-axis.
Reciprocal square root.
Okay, I'll agree with one of those. Which one do we agree with?
It's a bracket.
I go with reciprocal.
Okay, reciprocal. Does that have an asymptote, x equals 0? Yeah. Okay, that's what has an asymptote.
Logarithm.
And then logarithm function. Natural logarithm function also has an asymptote. So, natural logarithm, which is the equation y equals natural log of x, and reciprocal, which is the function y equals 1 over x. Now, that was vertical. Now, I want to talk horizontal asymptotes at y equals 0. So now we're talking about the x-axis. Which two functions have, which three have horizontal asymptotes at the x-axis?
Exponential.
Okay.
And logistic.
Exponential. It runs along the x-axis, so y equals e to the x. Reciprocal is the one that has both asymptotes, right? So that's y equals 1 over x. And then the third one here is logistic. So y equals 1 over 1 plus e to the negative x. Okay. Be working on pairing those names and equations up. And finally, does the graph y equals natural log of x have a horizontal asymptote?
No.
So here's natural log of x. We already talked about the vertical asymptote. Does it have a horizontal asymptote?
No.
Okay. And why? How do you know that?
Because our because our range is negative infinity.
Okay. If we state our range, if you recall the time, as going up to infinity. So it does not have a horizontal asymptote. It does go up infinitely. And I don't have an explanation to write down necessarily on that one other than just no. Okay, folks. On the homework. It's a lot. Make sure you write down the right problem, please. Okay, copy down the homework correctly.
Basically just
1 through 24, folks, is matching. Okay, there are going to be variations of our 12 graphs. You're matching the equation and the graph. Try and do it without using your calculator. The more you can get to do that by memory, the better, but you can use your paper, your notes, obviously.
well, that's the same thing.
13 through 18. Listen, 13 through 18. Notice it says, identify which of exercises 1 through 12 fit the description given. So on 13 through 18, your answers, if you look in the back of the book for odds, will say, like, okay, number 13, it says exercise blank. So I'm just looking for, like, which question from above goes with that, 13 through 18. I'm not looking for an equation in that section. Now, starting at 19, identify which of the 12 basic graphs. That's what we just did here. I'm looking for equations there. So that was up through 24.
So 13 through 18.
29 and 30. Wait, did I assign 29 and 30? Yeah, 29, 30, and 34 ask for you to graph it and find domain and range. 35, 38, 39, 41 is like example 4 from the notes. Okay? This homework. Don't procrastinate. Some of you won't be in school Wednesday because of the field trip, so you won't have Wednesday to work. And we're going to do lesson 1.4 tomorrow, and you will have a new homework to go with lesson 1.4. Okay? So don't procrastinate. Both will be due on Thursday.